Yesterday, we learned kind of a whole new universe of numbers. Okay, I'm just going to recap what we learned yesterday. So we learned that, okay, our numbers, okay, can be put into this box, okay, that we called real numbers. Everything that we learn about in grade 10 math, okay, are going to fit in the universe of real numbers. We're not interested in anything that's outside of this box. Okay, that's like university level. Okay, so our universe is considered real numbers. And then what we do is we cut a little, not half, okay, but we cut a chunk of the real numbers, okay, and we're separating it. Okay, in the smaller section are what we call irrational numbers. Okay, or what we called Q with a bar on top. Okay, in this bigger section, and it's bigger because there's more of them. In the bigger section here, we have rational numbers. Okay, and we use the letter Q for rational numbers. Okay, so remember, a rational number, okay, is any number, okay, that can be written as a fraction. Okay, so it can be like a whole number. It can be positive or negative. Okay, so for example, so I'm going to do some examples. Okay, 3 would be rational because, okay, we can always write 3 as a fraction over 1. Okay, so any normal number, okay, negative 17. Okay, we could write that over 1. Okay, we could do like 2/3. Okay, so anything that can be written as a fraction. So we have a fraction. Okay, and then we also talked about how, because sometimes when we have fractions and we like actually use our calculator and we divide it out, okay, the fractions when they turn into decimals, okay, we talked about when it's in decimal form that it has to be terminating, okay, or repeating. Okay, so this is kind of this is the big category of rational. Okay, it can be written in fraction form, or it's a terminating or a repeating decimal. Okay, which means if it's not one of those things, then we put it over in the irrational box. Okay, so this means non-terminating, okay, non-repeating decimals. Okay, so an example of this, okay, we talked about the pi button. We also talked about like the square root of 2. Okay, if you're to do the square root of 2, it would be some, okay, random bunch of decimals that fill your screen until the screen like stops printing them. Okay, so all these are rational numbers. Okay, then, okay, we also can subdivide rational numbers. Okay, so now we can kind of do this. Okay, so this is rational numbers, and then inside rational numbers, okay, we also have a couple little subdivisions. Okay, we said that, remember how we started, like when you first start counting and you learn how to count 1, 2, 3, 4, 5. Okay, so those are natural numbers. Okay, we also have, okay, then we added one. Okay, so who remembers when we added 0? What category are we in now? Yeah, whole numbers. Okay, the only difference between a natural number and a whole number is that whole numbers have a 0. That's it. Okay, and then we also included, then we said, okay, now let's also talk about positive and negative numbers. Those are called our integers. Okay, so our integers. So we have, and those are all, okay, a natural number, a whole number, integer are all rational, and they're all real. Okay. So you'll see in your notes, you'll see this cute little diagram. This one right here. Okay, that's kind of like what I just drew. So our universe of numbers are the real numbers, and real numbers are split into 2 categories, rational and irrational. And then rational numbers can be further split into integers, whole numbers, and natural numbers. Okay, if it's a fraction, it's not an integer. It's not a whole number, it's not a natural number, it's only rational. Okay, but if it was like the number -3, that would be an integer, and it would be rational, and it would be real. Okay, so some of the questions might ask you to identify all the sets that a particular number belong to. Okay, now what we're going to, like in yesterday's homework, right, there were some questions that asked you to identify if it was rational or irrational. Okay, and we got to learn our calculators a little bit because it was starting to throw like some weird, like, you know, a square root symbol, but it had a 4 in front of it. So we had to learn how our calculators want to, like, how we can change that index. Okay, so it kind of like jumped a little bit ahead because today we're really going to focus on, okay, taking a look at, okay, what we're calling a radical. Okay, because we can't just call it a square root. So when you were in junior high, you might have gotten into cube roots a little bit, but primarily, right, in elementary school, we talk about square roots. Okay, now we're going to be talking about a variety of roots. Okay, and so we just changed the word and we call them radicals because they're really cool. I don't know. Maybe that was like some math humor a long time ago. Okay, so here are the things that you need to know. Okay, this whole thing, okay, is called a radical. Let me like move it up here. Okay. All right, so let's say we had, I'm going to give you an example. Okay. Okay, this whole thing is called a radical. Now we're going to label some of the things. So the little number that is in front, okay, that one is called your index. Okay, this one's called your index. And so it shows it here like in general form. Okay, but I like using examples at this step. Okay, so the little number in front is called the index. And for most of us on our calculator, you type the index in first, right? Then we went to the math button on our calculator and we chose number 5 as the option. Let me pull up our calculator. Okay, so we did like the index first and then we did the math button and then we went down to number 5. Okay, and then we typed in our number. Okay, so that's how, now on my calculator, that little X disappears and it replaces it with the 3. Okay, a few of you have the TI-83, and so yours will just have the 3 out in front, and then it'll say X with the radical sign, with the root sign. Okay, and that's okay. Like your calculator still knows what it's doing. So if you have any questions, right? If my screen doesn't look exactly like your screen, and you just want to make sure that we're doing the same thing, okay, just let me know and I'll come around and help you out when you guys are doing your work. Okay. So this is the index. This, okay, this what we're used to being called a square root sign. Okay, we're just going to call it the radical sign. So we're just going to change your wording a little bit. Instead of saying the square root sign, it is now the radical sign. Okay, and then the number that's underneath the radical, okay, that is, okay, that's a radicand. Okay, you'll see it right there. It has a fancy name, the radicand. Okay, so our radical, the whole thing, has 3 parts. It has an index, it has a radical sign, and the number underneath is the radicand. Okay. Now, if you see something, like say you see, okay, if you see that there's no index, okay, that's listed, okay, you can assume that it's a 2. Okay, we're going to assume that it's a 2. It's a square root. Okay, so if the index is not written, it is assumed to be a 2. Okay, so there's actually no such thing as a radical with an index of 1. Okay, it just doesn't exist. Because what we're saying is, what this square root symbol means is we're like trying to figure out how many times something gets multiplied by itself, okay, and we're like undoing that process. Okay, we'll find out more about this stuff. So the index represents the number of times the radicand must be multiplied by itself to equal the radicand. Okay. So let's do some examples because so this is your high level language. Okay, so this is where we want to bring you. Okay, in the next couple of days, I'm going to be using words like index and radicand and radical, and you're going to get used to it and start to go, oh, okay, like I know what we're talking about. All right, so let's take a look at, make sure my examples are here. Okay, so at the top of the next page, it says indicate the index and the radicand of the following. So we're just making sure that we know what's what. Okay. Okay, so if you want, you could, circle the index. Okay, so someone tell me, what is the index of A? It's the 3. Okay, how about B? What's the index of B? 2. Awesome. Okay, if it's not written, okay, then we can assume that it's a 2. That's kind of hard to read. Let me make it, okay, a little bit bigger. Ooh, look at this. Okay, what's the index for C? It's only going to be one of them. It would be the 3. Yeah. Okay. The index is usually written a little bit smaller. Okay. We'll get back to like what the 4 is in a second. What is the radicand? Okay. Well, the radicand is what's left over, right? It's the thing that's under the square root. Okay. So if we were to like put a box around the radicand, okay, this is our radicand. This is our radicand. Now notice here, okay, sometimes the radicand could be a fraction. Sometimes it could be a decimal. Sometimes it could be positive or negative. Okay, all of those options are okay. Okay, given the right circumstances. Okay, we talked a little bit this yesterday. In order to have a negative under the radical sign, our index has to be an odd number. Okay, because we cannot take, so for example, we talked about this yesterday, how, okay, if the index is even, we cannot take the square root of a negative number. Okay, that will give you an error in your calculator. If you try to do the 4th root, okay, of a negative number, that would give you an error as well. Okay, so sometimes it's okay to have a negative sign under the radical sign, and sometimes it's not. It just depends on whether your index is even or odd. Okay, so these ones, okay, would not work. These ones would give you errors. Okay, but here the negative sign is okay because our index is odd. Now, does anybody know when we put a number in front of something? We've had this word, this vocabulary word come up before in our last unit. Does anybody know what the math word is for a number that's in front of, like a variable, for example? Yeah, coefficient. Okay. Coefficient. How to spell it, right? Okay, so write that in. That's called the coefficient. Okay, and the coefficient, okay, is always multiplied. Okay, so even though they don't write it, okay, there's like an invisible multiplication sign between the 4 and this radical. Okay, so just like when we had 4x, okay, and that meant 4 times x. Same with this. If we had 4, okay, the root of 8, this means 4 times, okay, whatever that number is. Okay, so there's a little invisible multiplication sign between the coefficient and the rest of the radical. Okay, so now what we're going to do is we're going to talk about perfect squares and perfect cubes. Okay, and we're going to fill out this chart, and I'm going to suggest that you might even want to get like a sticky note or a little scrap piece of paper and just keep this handy until the numbers become so familiar that they're locked into your brain, because we have to recognize our perfect squares for this unit to go smoothly. Okay, this is one of those foundational things. Okay, and so when I'm talking about a perfect square, okay, or squaring something, that means that I'm going like 1, and I'm using our little squared button on our calculator. Okay, so let me clear that. Okay, so if I'm doing 1, I'm looking for this x to the power of 2. Oh, sorry. I should try to clear all of that. Okay, 1 squared, that's what I'm doing. Okay, 1 squared is 1. 2 squared, okay, is 4. 3 squared is 9. Okay, so for some of you, you know these. Okay, you go ahead and fill in the chart with what all the perfect squares are. Others of you, pull out your calculator and you're going to start becoming familiar with that. Yeah. Yeah, absolutely. Let me just, while everybody's filling that out, let me push pause. Okay, well, I have my calculator up. Once you get to like the cubes, okay, or maybe a higher level of exponent, okay, see this little, we call it a caret, this little triangle top, okay? That allows you to choose any exponent, okay? So when you're filling out the cubes, right, there isn't a button, but you can't use this, you can't use this e to the x or 10 to the x. Okay, the way that you would do something cubed is you would type in like 3, you do the caret. Now, if you have an older calculator, the one on my desk, it would show me the little caret. If you have a newer calculator, it will show you that you've now entered into exponent mode. And then you just tell it what your exponent is. Okay, so then you'd go, I'm thinking my next one would be 4 cubed. So I'd do 4 caret 3. So if you hear me use the word caret, that's the symbol that I'm referring to, is this little one here. Okay, so let's see how we did here. Okay, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. That's as far as I know from my memory. Okay, I know up to my 13s. So I would have to do this one, okay, but it would probably be good for me to just become familiar with those final 2. Okay, and then cubed, usually we don't go much above 10. Okay, so you don't have, we don't really do any like 11 cubes, but these ones, 3 cubed 27, what did we say, 64, 125. Okay, now I have to look. Okay, so I know like up to 5 in my brain, and then I would have to just be a little bit more familiar with. Okay, 6 cubed, hopefully you got to 216, 343, 512, 729, and then we'll stop at 1,000. Okay, so this chart right here, okay, is good to have like while you're doing your work. If you were to write a quiz or a test, you might just want on your scrap piece of paper to write out the first 100 perfect squares, just so that like when you'll see why when we start getting into it, right? These are the special numbers that you're looking for once we start solving for some of the like the questions that we're going to be taking a look at. Okay, so again, if you're just a couple definitions, right? They're in your notes, so you should be able to look at them. Perfect squares, right? 2 numbers that are identical that we multiply. Every square root symbol is, okay, has that radical sign. Okay. Now here's something that interesting that you might not have, well, I think you would have covered it, okay, but just a reminder, okay. When we're talking about square roots, okay, so if we have an even index, okay, every answer that we have has a positive and a negative answer. So for example, okay, now here's the thing, your calculator will only give you the positive answer. Okay, so if you were to do square root of 9 on your calculator, okay, what would your calculator tell you? 3. Okay, but if you did -3 and you squared it, okay, that answer is also 9. Okay, so what we're going to be, one of the things that we're going to be looking at is when we take the square root of a number, okay, so a square root, index has 2, it's an even index, there's actually going to be 2 answers. So what it looks like is, say we had the square root of 9, we would say the answer is positive or negative 3. Okay, your calculator the calculator gives you what's called the principal square root. the positive one. Okay, it will never give you the negative one. That's you having to say, oh yeah, there's also a negative answer. Okay, so that's kind of top level. We'll get more into that as we go into our examples. So the perfect cube, okay, that's another example of the same number being multiplied by itself, right? So 2 times 2 times 2, okay, that's the same as 2 cubed, okay, which will give us 8. So then that means that if we take the cubed root of 8, we end up back at 2. Okay, so when we take the cubed root of any of these, so if I took the cubed root of 343, my answer would be 7. If I cubed 7, my answer would be 343. So you're seeing how exponents and radical signs are, again, those balances, those opposites, the way that we do one and then how we can undo it. Okay, so if we square something and then we want to get back to where we started, we're going to square root it, right? So, okay, we are going to, okay, I'll come back to the entire versus mixed in a second, okay, because I want to go through an example first. Okay, so we have, okay, what we're going to be doing in this for the next couple days is we are going to be writing things in simplest terms. Remember when we did fractions? Okay, and we always had to like reduce our fractions to lowest terms. So if I gave you the fraction of 4 over 8, I would expect you to say, oh, wait a minute, I can divide top and bottom by 4. My answer is actually 1/2. Okay, the same thing is going to happen with radicals. Okay, so what we're doing, okay, is when we see a radical, so here's an example. We have the square root of 32. Okay, we are going to look to see, like to break up 32 into its factors. Okay, but the only factor that I'm interested in is one that is a perfect square. Okay, so that's why this little chart here is so important. I'm only looking for factors that fall into this category. So I'm looking for factors of like 4 or 9 or 16 or 25. Okay, because those are the only numbers that can come out of a square root. Okay, because they're perfect squares. And so what we do is, okay, we have this radical and we're going to try to, we call it simplify. Okay, so when we simplify, we determine the largest perfect square that's a factor in this radicand. Okay, so what that looks like, okay, we could kind of say, okay, we would remind ourselves that, okay, 32 is equal to 16 times 2. Okay, we chose, okay, 32 has a whole bunch of factors, right? We could have gone 8 times, we could have done 8 times 4, but we want sort of like the GCF, we want the largest perfect square that's inside a radicand. Okay, and the largest perfect square is 16. Okay, then what we want to do, okay, so this is kind of like what we've done in our head. What we would write on our paper is we would write, so let me put the head space just a little to the side. Okay, so we would say 32 is the same as 16 times 2. So here what we would do, okay, is, okay, we would write it, so I'm underneath my 32, I would write that 16 times 2. I would keep it all underneath the radical sign, and then I can split them up. Okay, this is the same as saying the square root of 16 times the square root of 2. Okay, so I can pull apart a radical and I can kind of put it back together again, okay, if I'm multiplying everything underneath it. Okay, so they're both still under a radical sign, okay, and they're both still being multiplied. Okay, so here I'm recording the radical in terms of the perfect square and the other factor. Okay, and then I'm writing this single radical as 2 separate radicals. And now the perfect square, I'm actually going to take the square root of it. Okay, the square root of 16 is 4. Okay, so from now on, I'm going to go a little bit faster. Okay, I'm going to just, like, once we recognize which one is the perfect square, okay, I'm going to, you know, be assuming that you guys are keeping up with like the perfect squares and that we can take the square root of them. Okay, so the square root of 16 becomes 4, and we're left with, okay, the square root of 2. Okay, don't forget that there's still a multiplication in between those. Okay, so this is just simplifying. Okay, so we have what we call, so this part here, the thing that we started with, this is called an entire radical. Okay, so this part is an entire radical. What we end up with, okay, this is called a mixed radical. Okay, so an entire radical means everything's under the radical sign, and a mixed one means that there's a coefficient and a radical. There's a little bit of both. It's mixed up. Okay, so now we're ready for this definition right here. Entire versus mixed. So the entire means that the number is entirely under the radical sign, and a mixed radical means that there is a coefficient in front. Okay, in simplified form. Make sense? Hey, have you guys have done this before, or is this new? How many have seen this before? A couple people. Okay, so this is okay, or maybe it's been a while. Okay, so maybe we're dusting off some cobwebs, or maybe this is brand new for you. Okay. All right, so let's do some examples so that you guys can get some practice. Okay. Let's take a look at the next page. So you're going to see the word simplify. What that means is they want you to take that entire radical and they want you to change it into a mixed radical. So they want you to take a look at 54. Guys, we got to be so good with our factors. Okay, so two numbers that multiply together to get me 54, and one of them has to be our perfect square. Okay, so we're only interested in numbers like 4, 9, 16, 25, right? Our perfect squares. So we look at 54 and we say, okay, well, what are the factors of 54, and is that like, and what one is the perfect square? Okay, so I'm hoping that you're at the point where you can be like, okay, 54, 9 times 6. Like that your recall is good with that, okay? If your recall's not so good, then you're going to be taking out your calculator and you're going to go 54 divided by, and you're going to go through your list of perfect squares. 54 divided by 4 equals. Does it give you a whole number, or does it give you a decimal? Okay, 54 divided by 9. Oh, that's 6. Okay, that's my number. Right, so there are some strategies if your factoring isn't very strong yet, okay, but we're going to be doing a lot, but it will get stronger. Okay, and if that's something that you need some work on, okay, come let me know and I'll find you some things that we can practice with that. So what we're interested in, okay, so we're interested in the 9. Okay, I'm going to change my X, like my big multiplication, to a dot. Are you looking for someone specific?
I am.
All right.
Still,
Anna's here. Abby's away today. Okay, our volleyball ladies. All right. Okay, so we're looking for our two factors, and one of them has to be a perfect square. Guys, if you choose two factors and one of them is not a perfect square, we're not doing this right. Okay, our factor has to be a perfect square. Okay, so you're just going to write them, show that they're being multiplied, okay, and then you're going to show that you can write them. Okay, you're going to take that entire radical and you're going to separate it into two individual ones. Okay, they're still being multiplied together, and now you're going to take the square root of 9, which is 3, and you're left with root 6. Okay. So this is the simplified version of the root of 54. Yeah. 6 is not a perfect square.
oh, right.
Yeah. Now, here's one thing that you can do. If you want to double check your work, you can pull out your calculator and you're going to put in square root of 54 equals, and you're going to see what the answer is. And then you're going to go, well, let's make sure that we can put this in our calculator. Okay, so pull out your calculator and, okay, we're going to take a look at, okay, where our square root button is. So it should be above the squared button. So square root of 54, okay, and that equals 7.34 and a bunch of decimals. Okay, I'm not so interested in what it is. I just need to see the number. And then I'm going to take a look at what is 3 times, okay, the square root of 6. So your calculator knows that if you put them side by side, that it's multiplying. If you would like to hit the times button so that there's a times between them, you can do that too. Then I hit equals. Okay, all I'm doing is comparing these decimals. Are they exactly the same? Yes, they are. So that means that these two, the entire radical and the mixed radical, are equivalent, right? They're the same. So that means that I did my factoring correctly. So you could check, right, all of your simplifications by doing that. Okay, do you have to? If you're uncertain, absolutely. Once you gain confidence in it, I don't expect you to be checking every single one. Okay, but for ones that are maybe a little weird, you might want to just take a look at it. Okay, so let's take a look at this one. Okay, so I'm looking at 120. Okay, guys, this is just like product sum, right? We got to figure out the factors of numbers. Okay, but now our factors aren't all the factors that we have to consider. We're only considering factors that are perfect squares. Okay, so if you need a place to start, just start at the beginning one. Okay, I'm taking a look at 4. Okay, so I can write 120 as 4 times 30. Okay, and then I'm just going to split my radicals into 2 individual ones. I'm going to take the square root of 4, which is 2, and then I'm left with 30. Okay, now just like what we did when we did factoring, okay, with greatest common factor, how do we know that we pulled the biggest one out? Okay, you have to take a look at whatever radical you have left and just confirm that there isn't another perfect square as one of its factors. If there is, then you just need to do it again. Okay, you just need to like pull out something else. I'll show you an example of that in a second. Okay, so let's take a look at this one. Okay, we have a half. So half is our coefficient. Right now it's being multiplied by 252. Okay, so we're not interested in the half right now. We're interested in the 252. So pull out your calculators. Okay, and you're going 252. We got to find out what perfect square is a factor of 252. Okay, so we're going to like start with 4. Okay, 4 works, but it might not be the highest. So let's just check a couple other ones. Okay, so 252 divided by 9. Oh, that one worked too. 252 divided by 16. Okay, that one didn't work. 252 divided by, okay, I don't need to do 25 because it ends in a 2. So let's do 36. Oh, 36 worked. Okay, and you can see that my number's getting smaller and smaller. Okay, and so, right, this one actually had a couple to choose from. We found one at 4, we found one at 9, and we found one at 36. Okay, now I look at, okay, whatever's left over with 36, and I see that it's 7. Okay, there's no way there's a perfect square in 7. So I kind of know that I've reached the right one. Okay, this was, let me just write this down. 9 was 28. What was 4? 254. 63. Okay, again, as you become familiar with these, if I had chosen 4 and 63, I know that 9 is a factor of 63. So I know I didn't go high enough. Okay. So in this one, okay, the coefficient still lives in front. Okay, you don't have to do anything with the coefficient yet. Okay, you're just interested in the 252, and we decided that 36 times 7 was the winning combination here. So then I'm going to write it as 2 separate ones. Okay, so now I'm going to put my answer in brackets, right? The square root of 36 is 6. Okay, and it's still being multiplied by this root 7. Okay, can I clean this up a little bit? Absolutely. Okay, so if I do half of 6, okay, or 1/2 times 6, okay, I end up with 3. and then I still have my root 7. Okay, so what happens is if there's a coefficient, you keep it out in front, and then when you take the square root of something, it just gets multiplied by the coefficient that's sitting in front of your radicand. In front of your radical. Okay. So maybe if you need to, okay, write a note to yourself, okay, and just remind yourself that, okay, the number coming out of radical sign gets multiplied by the coefficient. Okay, I like to write myself notes all the time to just like what's going on there. Okay. Okay, then sometimes we like to make things interesting. Okay, here's a little one that has a bit of a fraction going on here. Okay, the way that radicals work is just like with multiplication, how I could take those two numbers that are both being multiplied together under the radical sign, and I could separate them into individual, okay, numbers being multiplied with their own square root signs. I can do the same thing with division. Okay, if I can rewrite this as the square root of 50 divided by the square root of 49. Okay, so I can pull apart a division question, okay, or a fraction as long as, okay, the numerator and the denominator each have their own radical sign. Okay, and then what I need to do, okay, I still need to individually, I still need to pull out the perfect square of both of these numbers. So when you're thinking of 50, okay, your little spidey sense should be going off going, okay, 25 times 2. 25 is one of my perfect squares. Okay, so then I'm going to write, I'm just going to write it beside because I'm running out of room here. So this is the same as 25 times 2. Okay, and 49 is a perfect square. Okay, so that just gets, we can just write its answer, 7. Okay, and then here I'm still going to write the square root of 25 by itself times the square root of 2 over 7, okay, which is square root of 25 is 5. Okay, and that's what this one looks like right here. So 5 times root 2 all over 7. Okay, so take a look at 128. Yeah. Can you wait till after lesson? Okay. So look at 128, okay, and start the process. Find out what is the perfect square that's hiding in 128, right, that we can pull out, okay, as one of the factors. I think with this one, I'm going to show you what happens if we don't pull out the highest perfect square. Okay. Tell me one of the factors that you found that was a perfect square. 64. Okay, awesome. Was there one that was less than 64? That's still perfect square. What did you find? 16. Okay, was there another one? Okay, probably 4. Right, we could do 128 divided by 4. Okay, so we had, again, we had some options. We had the option of 4, we had the option of 16, we had the option of 64. Okay, I'm just going to, here, I'm going to do it on a separate page just so that I can get lots of space. So this is the original question. Okay, I want to walk you through what would happen if you did this question and you didn't realize that there was a higher perfect square to pull out, because it's okay. We can still get to the right answer, but I'm going to show you that it's going to take a couple steps, It's always better to choose the highest one, okay? But you can still, sometimes we just miss it, right? But we can still get to the right answer. So say we chose 4, okay? Say we chose 4 and, okay, we're left with 32. Okay, so then we did this. 3, this is a big 3, not an index. Okay, we did the root of 4. Okay, okay, so we're here times. Okay, guys, I'm going to say put your answer to this in brackets so that you that it doesn't suddenly, like if you just write 2, your brain might squish 3 and 2 together and end up with 32. Right? Because our brains do strange things sometimes. So these are being multiplied. So if you keep it in brackets, then your brain will remember that you're multiplying them together and give you the 6. Okay? Now here's the thing. Okay? I would expect, why does that seem low? 128? Yeah. Divided by 4. Oh, okay. I would expect that you would just double check 32. Okay, like when you're done and you think you're done, you still have to double check. Okay, is there a perfect square still in 32? Hey guys, there is. Okay, so let's say I was like, oh yeah, I forgot 32. Okay, is I can still go 4 times 8. That will give me 32. Okay, so in that case, you got to go 6 and then you go square root of 4 times the square root of 8. Okay, 6 times 2, square root of 8. So now I'm at 12, the square root of 8. And then I'm like, okay, oh no, 8. 8 can be divisible by 4, which is a perfect square. So I got to do it one more time. Okay, 4 times 2. Okay, so can you see why I would encourage you to 12 times 2, okay, root 2 is equal to 24 root 2. Okay, it took a couple times, and we had to do a lot of recognition that, oh, there's still a perfect square in there. Oh, there's still a perfect square in there, until we got to the final answer. Okay, but I wanted to show you that if you could recognize that, you can still get to the right answer, even if you didn't get it in the first step. If we go all the way back up to the top, which is like a long way away, okay, so we were also told, okay, that we could have chosen 16. Okay, 16 fit in there, so 128 divided by 16. Okay, it was 16 times 8. Okay, this would have been better. Okay, but it would have still, okay, we would still have to recognize that square root of 8 can still be simplified. Okay, so it's going to take a little bit of practice for us to so always check up a few more, even if you find one at the first number. Okay, we found another one, and what we're going to find is, okay, if we had done 64 times 2, okay, this would have saved us a lot. We would have got there in this many steps. Okay, instead of, are you ready? All the way down here. Okay, it just saves you so many steps if you can find the highest square root that is a factor. Okay, so don't stop. If you hit it with 4, try 16. If 16 works, try 36. Okay, if that works, try, maybe it works, maybe it doesn't, try 64. Just try a couple. Don't stop with the first one that you get. Okay, because this one was still, I didn't finish this one up. This one was still going to take us some time. Okay, so I just wanted to show you that it is possible. Okay, but every time that you miss one, right, we just got to take a few more steps in order to finally get there. Right, back to our question. So let's go with Xavier's first suggestion and do the 64 times the 2. Okay, if you're feeling good, okay, keep going. Let me put a box around that. Okay, so now the next one though is a cubed root. Okay, so that's where you go to the other column in your notes and you take a look at your cubed roots. Okay, so the ones that, again, that should become really familiar, 8, okay, is a perfect cube. 27 is a perfect cube. 64 is a perfect cube. Okay, 64 is an interesting one because it's a perfect cube and it's a perfect square. So just depending on the question, okay, your answer will vary whether they're wanting you to do cubed or squared. So in this case, right, 8, I know that 16 can be 8 times 2. 8 is one of my perfect cubes, so that's the one I'm honing in on. That's why I chose 8, because 8 is a perfect cube. Okay, so I want 8 times 2. Okay, now you need to include this is a times, not a subtract. It's kind of a big. Okay, now you need to write in your index so that you can remember that it's being cubed. All right, so the same process, you can pull out, okay, so when two things are being multiplied together under the radical sign, you can give them separate radical signs and still multiply them together. That's an equivalent. Okay, the cubed root of 8 is 2, and I'm left with the cubed root of 2 as my answer. Okay, now I'm looking for a cubed root in 54. Okay, so I would go, okay, 54. We could try 8, okay, which I know that's not going to work, so I'd go 54. I'm going to try 27. 27 times 2 gives me our 54. Right, so I'm just sharing my thinking process. 27 times 2. Okay, and the cubed root of 27 is 3, and then we're left with the cubed root of 2. Okay, so we're moving from entire radicals. We're doing something called simplifying, and we're changing it into a mixed radical. Okay, if you're feeling pretty good, I want you to try H and I, and I'm just going to come around and make sure that we're doing okay. Okay, I'm going to help fill in the rest of these, so check the ones that you already have done, okay, or follow along if you haven't quite finished those ones up. Okay, the cubed roots. So again, whenever you're checking, you're always going back to this chart, and these are the cubed roots that you are seeing if those would be factors in these questions. Okay, so 128, okay, I found that if I do 64 times 2, okay, that's my perfect cube. Okay, 64 times 2. Okay, I'm keeping my negative 2 out in front. Okay, I'm just separating the 2 into individual radicals. Okay, and then I'm doing negative 2 times, okay, the cubed root of 64 is 8. Nope, sorry, cubed root of 64 is 4. There we go. Okay, and now I'm just cleaning it up a little bit. I'm going negative 4 times negative, sorry, I'm doing 4 times negative 2, which gives me negative 8 times the cubed root of 2. Okay. In this one, I'm doing a cubed root and it ends in a 5. So I'm right away going to go to my 5 to the power 3, right, which is 125. And I'm going to check. Is 125? Oh, that was weird. Okay, is 125 a factor of 375? Yes, it is. Okay, so we're going to leave the coefficient in front. We're going to split this into 125 times 3. Okay, the cubed root of 125 times the cubed root of 3. Okay, do not be fooled that, like, if the index matches the inside, that they have anything to do with each other. Okay, the cubed root of 3 does not magically become 1 or it doesn't add, or it doesn't multiply. It just is the cubed root of 3. Okay, you can't simplify it any more than that. So this is the coefficient. I'm going to take the cubed root of 125, which is 5. Okay, so I end up with 25 and the cubed root of 3. Okay, heading over to J, I'm at 600. I'm back to my square root, right? My index is 2. So I'm looking for my square root. And as soon as you see zeros, think 100. Okay, so 100 is an awesome perfect square. So I'm going to keep my coefficient in front. I'm going to do 100, okay, times 6 under my square root sign. That's the same as saying, okay, 100 times 6 that way. So for square root of 100 is 10. Okay, so I end up with 40 times the square root of 6. Okay, 243, looking at square roots. Okay, so I'd go to my calculator. Okay, 243, I'm not really sure. Let's try 9. Okay, 9 and 27, but 27 can still be 9. So you know what? When you have something, like I chose 9, and that my answer ended up being a multiple of 9, okay, just take 9 and 9 and multiply them together. Okay, 9 times 9 is 81. So check to see if 243 can be divided by 81. Okay, and it can be. So that's one way of like upping your perfect square factors. If when you try one and the leftover is still a multiple, then you just take those, okay, and you can use kind of what you found out. Okay, so this one, the negative, okay, if there's a negative in front, okay, what is the negative? Negative is always attached to a number. What's the invisible number that the negative is attached to here? A 1. The 2 is the index, okay, but the negative sign is a negative 1 being multiplied by, okay, 81 times 3 underneath our radical sign. Okay. So then when we take the square root of 80, oh, sorry, we have to put them in separate signs. Take the square root of 81. Okay, so just remember, okay, to multiply it gives you negative 9 times the square root of 3. Okay, so that's what happens when there's just this like floating negative sign. It's actually a negative 1. All right, and then my final one here. Okay, we haven't really talked about fourth roots, but the same thing would apply here. We're looking for a number multiplied by itself 4 times. And this one actually ends up being 2 times 2 times 2 times 2. Okay, and when there's 4 of them, okay, my answer is 2. Okay, and you could actually do that one on your calculator, right? You could do the fourth root. Okay, so we're going to continue with the lesson tomorrow, okay? But I do want you guys, when you get home tonight, I do want you to just flip over to the next page that has your homework listed. Okay, I do want you to, okay? Okay, I want you to do 4, 9, the ones listed for 10 and the ones listed for 11. Okay, we'll do 16 and 21 later, okay, but this is going to be for homework so that you can practice some before you come back to class tomorrow. 2.